Hello everyone. So now we are going to do the Eigrp. If you remember in our previous class we finished the OSPF. So now we are going to discuss this Eigrp. So let's start. This is also routing protocol. If you remember, let me write here. In our previous class when we start the routing protocol we discuss, that is we have the static, dynamic, default. Let me write here. Routing we have different types. As we discussed before, we have routing, we told static, and we have default. Generally default we use to send the traffic to ISP, and then we have the dynamic. In dynamic, no need to no need to show the path. Automatically router is going to learn the routes. In static we need to do manually. In static we are going to do the manually. Let me allow, I think someone is joining. Okay, so what I am saying here, routing we already discussed. When we start, we have the static routing, default routing, dynamic routing. Manually we are configuring in the static routing, as well as default also we are doing manual configuration. Why we are using default? If we don't know the destination, we will configure the default route and we will forward the traffic towards the ISP, as we discussed before. And in the dynamic routing protocol we have the RIP version 1, version 2, and we have the OSPF. Okay, we have the OSPF. Okay, so we have the OSPF and we have the Eigrp. We have BGP also. So this one we already discussed. Now we need to go one by one in detail. So if you remember this one, from here to here we told interior gateway protocol. Interior gateway protocol, IGP, means we are going to use this inside the organization. And BGP is a exterior gateway protocol. So we finished this one. This one also we finished. Now we are going to start the Eigrp. Okay, Eigrp. This is also a dynamic routing protocol, and this one is a interior gateway protocol we are going to use inside the organization. And we have BGP. BGP, when we finish the Eigrp, we are going to start the BGP. So now we are going to discuss the Eigrp. Eigrp, before it is Cisco proprietary. It will work only in the Cisco device, but now it is open. It is open, so everyone can use, even Cisco as well as the Juniper or Hawaii, Nokia, different vendor can use this routing protocol Eigrp, because now Cisco opened this protocol, that is Eigrp. So let's see some basic points of Eigrp. After that we are going to learn how we can configure and what are the advantage we will have. What is a hello timer, what is a dead timer, what is bandwidth, and how we can calculate the bandwidth. We are going to learn that one. So first of all, we need to remember Eigrp stands for Enhanced Interior Gateway Routing Protocol. And before, this will work only in the Cisco devices only, but now after 2013 Cisco opened this one, so this is a open standard. Anyone can use this one. It is a hybrid routing protocol. Sometimes it is called as a advanced distance vector. In some books they mention advanced distance vector. It is a hybrid mix of the distance and link. It has the characteristics of both distance vector and the link state protocol, and it uses the dual algorithm. This is very important. We need to remember dual algorithm. Dual means diffusing update algorithm. OSPF is using the Eigrp is using the dual algorithm, that is a diffusing update algorithm to select the best path. Because in interview you will get the question Eigrp is using which algorithm. So we need to tell the dual algorithm, and full form of the dual diffusing update algorithm, and it is using RTP, that is a reliable transport protocol, to communicate the neighbor, and also it is using the multicast to update, to send the update. It is supporting both IPv4 IPv6, and whenever they are sending the update, they are including the subnet. Like when we have one router here R1 and we have another router here R2, whenever there is any update, when this guy is sending the update, this guy is sending the update, they will send the subnet mask also along with that update. And here also we can do the summarization, root summarization we can do in Eigrp also. If you remember, we done in the we done before in the OSPF. So same like that we can do in the Eigrp also. And here it is supporting the VLSM, variable length subnet mask, or CIDR, classless interdomain routing. That means subnetting. So what we can say, Eigrp is supporting the subnetting. So instead of having like this IP, if you have 192.168.1.1/24, instead of this one you can use 22, 26. After subnetting, whatever you are getting the IP, maybe 32, whatever IP you are getting after subnetting, it will work in the Eigrp. And what else? The important point here is hello timer. Eigrp hello timer is 5 seconds, dead timer is 15 seconds. This is also important. In interview you will get this question also. So hello timer for Eigrp is 5 seconds, dead timer is 15 seconds, and AD value, I hope you remember the AD value. AD value is 90. Okay, by default internal AD value is 90. If the roots are coming from external Eigrp, then the value will be 170. Now we need to remember Eigrp is having the internal AD value as a 90, external AD value as a 170. Eigrp default hope count support 100. So when we want to configure the Eigrp, we need to keep in our mind that we can configure Eigrp in 100 router. Like if you have one network, you have 100 router in that one, it will work as a Eigrp. If you have 101, it will not work. Whereas in OSPF we can connect unlimited routers, but in the Eigrp we have the limit, we can use 100. But we can tune also. We can tune from 100 to 255. Okay, but we have limit here. But in the OSPF we can connect unlimited. And here one more point, Eigrp support equal cost and unequal cost load balancing. So this is very important point we need to remember. In interview they will ask you what is the main difference between OSPF and Eigrp. So you can say Eigrp is doing the equal cost load OSPF is doing the equal cost load balancing, whereas Eigrp is doing both equal cost load balancing as well as unequal cost load balancing. So this is very important point you need to remember. In OSPF only equal cost, whereas Eigrp protocol equal and also unequal cost load balancing will work here. And it will do the load balancing by default up to 4 path. 4 means, example, you have R1 here, you have R2 here, you connected with the 4 cable. Okay, so it will do load balancing by default 4 cable. If you connect 5th one, it will not take this one in the consideration. Whatever you connected first, you will take that one only. But if you want to change, we can change. We can make the changes in the configuration from 4 to 32. So maximum it will support 32. But generally we are using only 4. We are not increasing in the production network. But you need to remember, if we want to change, we can change. That is load balancing from by default 4 to 32. And whatever the updates, it is going to send with the multicast, and multicast IP is using the Eigrp 224.0.0.10. And it is supporting the MD5 authentication. MD5 is a message digest file. This is a authentication technique, so it is supporting this technique. By default, auto summarization is enabled. In the Eigrp, auto summarization is enabled by default, where in OSPF it is not enabled, but in the Eigrp it is enabled. So we can disable also, because by default they will not do accurate summarization in some scenario. So better do manual summarization. Anyhow, we will see that one. In the Eigrp we have the different table as we have same like in our OSPF. So it maintains 3 table. We have the neighbor table, we have the topology table, and we have the routing table. In neighbor table we will have the neighbor detail, and in the topology table we will have the complete topology detail. In the routing table we will have the best path. Now we need to remember, in Eigrp we have 3 table: neighbor table, topology table, routing table. And now let's see how we can configure. How we can configure the Eigrp. If you see, same as we do before, we will write router Eigrp. Here we will write the AS number. AS, autonomous system number. AS number we will write here. You need to remember, if you remember before, example, if I have R1 is connected to R2, example here is fast Ethernet 0/0, here also fast Ethernet 0/0. When we are configuring the OSPF, we are writing router OSPF 1, and then whatever the interface, example like this, fast Ethernet 0/0, IP OSPF 1 area 0, like this. And for this router we can write different number also, process ID, that is router OSPF. Instead of 1 I can use 2 also, but I think we did not do that one. You can try. In the OSPF, here we can use 1, here we can use 2, no problem, it will work in the OSPF, but in Eigrp it will not work. If you are configuring Eigrp, whatever the AS number you use here, you need to use same in the Eigrp, but OSPF no problem. So what I can say, like router Eigrp, and I will give 1, and whatever the network, we need to write network and the network ID. Example, if I am using 192.168.1.0, and then we need to write no auto summary, because by default manually, by default the router is doing the summarization, so we don't want the summarization, so we need to write this is only the configuration. And you need to remember, in R1 if you are doing this configuration, in R2 also you need to use the same AS number whatever we use here. In OSPF no problem, we can use anything, but Eigrp same AS number should be both side. So this is a syntax for configuration of the Eigrp. So we need to remember this syntax. We will do lab, so you will have more idea. Like this is a basic lab we can do. What I done here, I write here I taken 2 router, we taken the IP schema 192.168.12.0. so here will be 12.1, here will be 12.2, here 1.1.1.1. I give one loopback here, another loopback here. Why I give loopback? Because I don't want to connect to the switch, or I don't want to connect to any other router, just I want to show I have one LAN network here. So instead of using the switch or any router or any client connect to the router, I create the loopback directly, and then we are going to run the OSPF. How we are doing, then we will run the Eigrp. So what is the command? This one, router Eigrp 1, then network ID, whatever interface you want to advertise, that network ID you need to write. Here I have one interface, here one interface, so we will write that network ID. Then no auto summary, same thing we will do, but you need to remember here, if you are using 1 here as a AS number, here also 1. If you mismatch, it will not form the neighborship. Anyhow, we will do that one. And after that, if you want to check the root, how we will check? We will write show IP root or show IP root Eigrp. Okay, so with this one we can check that. So anyhow, we will do one lab, so we will have the idea what we are getting and how we can read that one. You can do this lab in GNS3, EVNG or Packet Tracer. Anywhere we can do this lab. Let me stop this theory.